In this video, you will learn how to make an Ansys Rocky two-way structural coupling with Ansys Mechanical. With this coupling, it is possible to send forces from Rocky and receive back the boundary displacement from Mechanical using system coupling. The two-way structural coupling uses the transient structural system inside Workbench. If you didn't watch the previous Ansys how-to video about Rocky two-way thermal coupling with Mechanical, go to the link in the description to learn how to do the setup on Rocky's side. The structural setup is the same as explained in the thermal coupling video. However, for the two-way structural coupling, you must select the structural option in the coupling type. The difference on the mechanical side, when compared to the two-way thermal coupling, is that Workbench will now use the transient structural system. The setting up of the model data tree follows the same default structural process, with only the system coupling regions, as already described for the thermal process. Note that in some cases, if the time step is not set to a smaller number, the mechanical solver may not converge and a high element distortion message will be displayed in the system coupling UI. After the mechanical setup, the system coupling region must be exported. On the system coupling side, the initial steps are still the same. The only difference will be in the Add Data Transfer parameter, which will now display the Add FSI Data Transfer option. It will mainly connect Rocky's forces data and send it to Mechanical. During the system coupling solving process, note that now the data transfer will be the force from Rocky to Mechanical, and incremental displacement from Mechanical to Rocky. The latter part is dependent on post-processing. The two options presented in the last video remain. Use EnSight directly from the system coupling UI, or open Rocky and analyze the DEMSPH trajectory and the displacement results. In EnSight, new variables are available such as force, incremental displacement, and displacement since mesh import, and in Rocky, the displacement property will appear. In Rocky, the already known post-processing options will be available for this two-way structural coupling case, with the new displacement option, that is the incremental displacement, calculated by Mechanical. Finally, here are some examples of applications of the two-way thermal and structural coupling process using Rocky and Mechanical. Thermal coupling can be used to analyze industrial heat exchangers in sectors such as maritime, food processing, production lines, air conditioning systems, and oil stations. It can also be used to solve the heat treatment process of metallic components, in which temperature variations and the impact on material properties can be analyzed. Whereas structural coupling can be used in a wide variety of applications, such as analyzing the structural forces and deformations involved in the mining industry, analyzing the plastic deformations and residual stresses on the shot peening process, or even to solve the complex interactions in the extraction and transportation of sand. To learn more, access the Ansys Rocky manuals and the Ansys Rocky Innovation Space. The links are in the description.